Hi students, I am continuing the chapter continuity and differentiability, and today I am going to discuss some problems related to derivatives of exponential function and logarithmic function. So listen carefully. Exponential function and a logarithmic function. Today I am going to introduce two new derivatives of function. First function is f of x equal to e raised to x, and this function is called natural exponential function, and second function is log x, and this function is known as logarithmic function. The derivative of exponential function, that is e raised to x, is equal to e raised to x itself, and derivative of log x is equal to 1 by x. So this is our two new derivative of functions. Okay, derivative of e raised to x equal to e raised to x, derivative of log x equal to 1 by x. So let's do some examples. Let us consider y equal to e raised to minus x. We need to find the derivative of e raised to minus x. So, let us name it as equation number 1. Differentiate equation number 1 with respect to x on both sides. We get y become dy by dx, and e raised to derivative of e raised to x. We know that the standard form of derivative of e raised to x is e raised to x itself, but here is e raised to minus x. So, if derivative of e raised to x is e raised to x, then derivative of e raised to minus x will be e raised to minus x into minus x is another function. So, here I am going to use chain rule. So, we need to find the derivative of minus x here and multiply with the first term e raised to minus x. This will gives the derivative of our function, which will be equal to minus e raised to minus x into derivative of minus x is minus 1. So final answer will be dy by dx equal to minus e raised to minus x is the answer. Okay. Next example is let y equal to sine of log x. Y equal to sine of log x. Here dy by dx equal to, differentiating on both sides, we get dy by dx equal to derivative of sin x is cos x, but here is we need to find the derivative of sine of log x, so it become cos of log x, replacing this x by log x, and here log x is another function. So we need to use the chain rule here, and we need to calculate the derivative of log x. So I write derivative of log x here, which will be equal to cos of log x into derivative of log x is 1 by x. So I write here, the final answer is cos of log x whole divided by x. Okay. So here I am using chain rule because this question consists of two functions. First one is sin x and second one is log x. Okay. So let's move to another example. Let y equal to log of log x. Differentiate with respect to x on both sides, we get dy by dx on LHS, and RHS become, we know that the standard form of derivative of log x is 1 by x, but compared to this, Here x is log x, right? So replacing this x by log x, we get 1 by log x. Here log x is another function. Using chain rule again, we need to find the derivative of log x and multiply with our first function. So answer will be 1 by log x into derivative of log x is 1 by x. So rearranging this, we get 1 by x into log x. And this will be our answer, derivative of y. Okay, which is equal to 1 by x log x. Next example is log of x square equal to y. So we need to differentiate with respect to x on both sides. We get dy by dx equal to, we know that the standard form of derivative of log x is 1 by x. Here comparing these two, here x, instead of x, here x square. So replacing this x by x square, we get 1 by x square. X square is another function. Here again I am going to use chain rule. That means we need to find the derivative of x square here. So 1 by x square into derivative of x square is 2x. So cancelling these 1x from numerator and denominator, we get 2 by x, and this will be the answer of our question. Okay, this is our first question. In this question, we need to find dy by dx if y equal to e raised to x divided by sin x. So let's start the solution of this question. Given that y equal to e raised to x divided by sin x. So let it name it as equation number 1. Differentiating equation number 1 with respect to x on both sides, we get y become dy by dx. Here it's a fraction, right? E raised to x is a function and sin x is another function. So here we need to use the quotient rule, right? U by v method or quotient rule. That means u by v whole dash equal to v into u dash minus u into v dash whole divided by v square. That means denominator into derivative of numerator minus numerator into derivative of denominator whole divided by denominator square. So next I am going to apply quotient rule here. Here u is equal to e raised to x and v is sin x. Okay. U dash means derivative of first function. That means here u is e raised to x. We know that the derivative of e raised to x is e raised to x itself, right? Next, v dash is, if v is sin x, v dash will be a derivative of sin x is cos x, right? So substituting all these values to our quotient rule, our RHS become v into, here v is sin x into u dash means a derivative of numerator. Here we get e raised to x as u dash minus, don't forget to write minus here. Next u into, here u is e raised to x, v dash is cos x into cos x whole divided by denominator square. Here denominator is sin x, so sin x square means sin square x. Okay. If you observe the derivative of this thing, e raised to x is common in both terms, right? So taking e raised to x outside, we get sin x minus cos x. E raised to x into sin x minus cos x divided by sin square x. This will be our answer, dy by dx. Okay. In this question, we are just applying the quotient rule and we get our answer, dy by dx. Okay. We know that the derivative of e raised to x is e raised to x itself and derivative of sin x is cos x. Here u dash v dash represents the derivative of numerator and derivative of denominator. Okay. It's another representation of u dash is the another representation of d by dx of u and v dash is the another representation of d by dx of v. Okay. This is our next question. In this question, we need to find the derivative dy by dx if y equal to root of e raised to root x. Okay. So let's start the solution of this question. Given that y equal to root of e raised to root x. We know, let it name it as equation number 1 and differentiating equation number 1 with respect to x on both sides, we get the derivative of y is dy by dx. Here, we know that the standard form of root x, standard derivative of root x is 1 by 2 root x. Standard form of root x is 1 by 2 root x. But here x, instead of x, it is e raised to root x. So if derivative of root x is 1 by 2 root x, then root of e raised to root x become 1 by 2 root of e raised to root x into, here e raised to root x is another function, right? So using chain rule, we need to calculate the derivative of e raised to root x. Okay. Again, we know that the derivative of standard derivative of e raised to x is e raised to x itself. But here instead of x, here root x is present. So we need to replace x by root x here. So the remaining terms are same. 1 by 2 into root of e raised to root x into derivative of e raised to root x become e raised to root x. Okay. Here root x is another function. So by using chain rule, we need to calculate the derivative of root x. So write derivative of d by dx of root x here. Again, we know that the standard derivative of root x is 1 by 2 root x. Finally, we replace derivative of root x by 1 by 2 root x. So the remaining, the first term and second terms are remain same. So write first term 1 by 2 root of e raised to root x into e raised to root x into derivative of root x will replace by 1 by 2 root x. Rearranging this one, we get 1 e raised to root x whole divided by 4 into root of x into e raised to root x. We know that root x into root y can be also write as root xy. So we can write root of e raised to root x into root x by root of x into e raised to root x. Okay. So this is our finally we got our derivative as e raised to root x by 4 into root of x into e raised to root x. Okay. Note that here 3 different functions are there. So we need to calculate 3 different derivatives of functions. First one is in the form of root x, second one is in the form of e raised to x, third one is again root x. So we need to calculate three derivatives of function. I hope you understood the question very clearly. This is our third question. In this question, we need to find the derivative of sine of tan inverse of e raised to minus x. Given that, so let's start the solution of this question. Given that y equal to sine of tan inverse of e raised to minus x. So let it name it as equation number 1. Differentiate equation number 1 with respect to x on both sides. We get the derivative of y means dy by dx, which is equal to we know that the standard derivative of sin x is cos x, but here we need to calculate the derivative of sine of tan inverse of e raised to minus. So replace this x by tan inverse of e raised to minus x. We get the answer. So we get if derivative of sin x is cos x, then sine of tan inverse of e raised to minus x become cos of x is replaced by tan inverse of e raised to minus x into tan inverse of e raised to minus x is another function, right? So we need to apply chain rule here. So multiply with derivative of this function, that is tan inverse of e raised to minus x. Again, we know the standard derivative of tan inverse x is equal to 1 divided by 1 plus x square. But here it is tan inverse e raised to minus x. So answer, if we replace x by e raised to minus x, this will lead to the answer of derivative of tan inverse e raised to minus x. So cos of tan inverse of e raised to minus x, this terms remain same. So I write here first into derivative of tan inverse of e raised to minus x is 1 divided by 1 plus, here x is replaced by e raised to minus x, because we need to calculate the derivative of tan inverse of e raised to minus x, not x. Okay. So here x is replaced by e raised to minus x whole square into, here e raised to minus is again a function. So by using the chain rule, we need to calculate the derivative of e raised to minus x. E raised to minus x, derivative of e raised to minus x. Once again, I write here cos of tan inverse of e raised to minus into 1 divided by 1 plus e raised to minus x whole square into derivative of e raised to minus x, because e raised to minus x is another function. So we need to apply chain rule here. Again, we know the derivative of e raised to x is e raised to x itself, right? So, but here these two terms remain same. So, I write these terms here minus x all square into, okay. If derivative of e raised to x is e raised to x, then derivative of e raised to minus x become e raised to minus x into, here minus x is again a function. So here we need to apply again chain rule. So we need to find the derivative of minus x and multiply with this answer will leads the final answer. Okay. And what will be the derivative of minus x? We know that the derivative of x is 1. So, derivative of minus x is minus 1. Okay. So, substituting the value of derivative of minus x here, we get cos of tan inverse of e raised to minus x into 1 divided by 1 plus e raised to minus x all square into e raised to minus x into minus 1. So, I am going to rearrange this answer by negative e raised to minus x into cos of tan inverse of e raised to minus x whole divided by 1 plus e raised to minus x whole square. We know that by using law of exponent, x raised to m whole raised to n is x raised to mn. So, e raised to minus x all square by using this law of exponent become e raised to minus 2x. So, last step, I am going to write the denominator by 1 plus e raised to minus 2x. So, this is our derivative of sine of tan inverse of e raised to minus x. The final answer will be e raised to minus of e raised to minus x into cos of tan inverse of e raised to minus x whole divided by 1 plus e raised to minus 2x. I hope you understood. Here we can see that our function y consists of 4 different functions. First one is in the form of sin x, second in the form of tan inverse, third in the form of e raised to x, and the last and fourth one is in the form of minus x. So, our function consists of 4 different functions. So, we need to calculate the derivative of these 4 different functions by using a chain rule. Okay. This is our next question. This question we need to find dy by dx if y equal to e raised to x plus e raised to x square plus etc. plus e raised to x raised to 5. So, let's start the solution of this question. Given that y equal to e raised to x plus e raised to x square plus etc. plus up to e raised to x raised to 5. Means next one is e raised to x cube plus e raised to x raised to 4 plus e raised to x raised to 5. So, we need to find the derivative of all these exponential functions. So, let's start the solution of this question. Let us name it as equation number 1. Write differentiate equation number 1 with respect to x on both sides. Derivative of y means dy by dx. Right. So derivative of e raised to x plus e raised to x square plus e raised to x cube plus e raised to x raised to 4 plus e raised to x raised to 5. By using algebra of derivative, we need to calculate a derivative of each exponential function separately. Okay, so that means this one is equal to derivative of e raised to x plus derivative of e raised to x square plus derivative of e raised to x cube plus derivative of e raised to x raised to 4 plus derivative of e raised to x raised to 5. And close it with bracket each function and close it with the bracket. Okay, so I'm starting with the this one, dy by dx equal to, we know that the standard derivative of standard derivative of e raised to x equal to e raised to x itself, right? So I write the answer derivative of e raised to x is e raised to x plus next one is derivative of e raised to x square. If derivative of e raised to x is e raised to x, then derivative of e raised to x square become e raised to x square. Here x square is another function, so here we have to use chain rule here. So we need to calculate the derivative of x square and multiply with this the first term plus next we need to calculate the derivative of e raised to x cube. The similar way we know that derivative of e raised to x is e raised to x, then derivative of e raised to x cube become e raised to x cube into, using chain rule, we need to write derivative of x cube here plus similarly here we get e raised to x raised to 4 into x raised to 4 is another function. Then write derivative of x raised to 4 here plus in next case also we write x raised to 5 here and also derivative of x raised to 5 here. Okay. Which will be further equal to e raised to x plus e raised to x square into derivative of x square is 2x. We know that the derivative of x raised to n is nx raised to n minus 1, right? So by using this formula, the derivative of x square become 2x, derivative of x cube become 3x square, derivative of x raised to 4 become 4x cube, and derivative of x raised to 5 become 5x raised to 4. Okay, substituting all these answers in this step, we get e raised to x cube into 3x square plus e raised to x4 into 4x cube plus e raised to x raised to 5 into 5x raised to 4. Okay. Rearranging this answer, we get e raised to x plus 2x into e raised to x square plus 3x square into e raised to x cube plus 4x cube into e raised to x raised to 4 plus 5x raised to 4 into e raised to x raised to 5. This is our final answer. So we get dy by dx is e raised to x plus 2x e raised to x square plus 3x square e raised to x cube plus 4x cube into e raised to x raised to 4 plus 5x raised to 4 into e raised to x raised to 5 is the derivative of e raised to x plus e raised to x square plus e raised to x cube plus e raised to x raised to 4 plus e raised to x raised to 5. So don't forget, here onwards, that means the second terms onwards, I'm using chain rule here. Okay. Using this derivative, standard derivative of x raised to n, and we get all the answers of this derivative. Okay. I hope you understood.